For the roller coaster project, our model this time is going to be one where we have a smooth track like you see on the screen, but we're going to be looking at modeling the motion of a car down that track, also with the addition or possible addition of a motor to drive that particular cart. So as a quick demonstration here. Here we saw a little motor on sign there for a second at the beginning, and then once we start the simulation, and again this will all be done in MATLAB, we can model the rolling back and forth of the ball, which didn't quite make it over the top of the hill. Now if we do a different model and run the motor for longer, then we can start to see scenarios where if we run it for longer, then we'll actually reach the end of the track going over any humps. So that'll be the kind of control we have, as well as the shape of the track. One of the typical design challenges for this flavor of task, or this design series, is to launch things into space off the end of the track, as demonstrated. I'll run that again. And the idea is you have the motor on for a certain fraction of the time, and then you'll have control over the shape of the track. And if you have that control, you can make it a goal to try to land as far as possible. One of the techniques we're going to look at in the class is optimization, where we try to get MATLAB to tweak the parameters, in this case the shape of the track, so as to maximize the distance traveled by the car after it launches. And so that'll be one of the challenges, or at least the flavor of the challenges in this design task.